Hello all, welcome back to my YouTube channel all about VLSA. From this session, we are going to start with a new project which is RISC-V IP code design. So this is what we are going to develop a particular RISC-V IP core which is going to have pipeline stages, arithmetic and logic unit, register control unit, memory subsystem, privilege and exception handling, peripheral and SOC integration. This we will see. Like if we have time, we will integrate them and we will add them. And this also, but this particular four stages we are going to implement. And in the core pipeline stages, we are going to have IFU unit and IDU unit, execution unit, memory access unit, write back unit, and in the arithmetic logic unit, we are going to have ALU, multiplier, divider, floating point, and in register control, we are going to have register files, control unit, and decoder, and so on, right? And this is my memory subsystem, which is going to have cache memories over here, which is being connected with my privilege and exceptional handling using the bus interconnect. So this is the basic overview of what we are going to implement during this particular course of RISC-V IP code design. And if I want to briefly explain about each and everything, so this is what. So IFU unit, basically it is used for fetching the instructions from program memory using the program counter. There will be something known as program counter that is basically used for fetching the instructions from instruction memory. This particular file we are going to develop using Verilog. And instruction decoder unit, like we are going to have a specific set of instructions. That particular instructions we need to decode. Like if I want to understand what is that particular instruction, I need to decode it. And after decoding, I need to execute them. And also I'm going to have something known as memory access unit for accessing different kind of my memory. And write back unit, basically it is going to write the computed result from the ALU or memory back to the destination register in the register file. So for that I'm going to have this write back unit. Anyways, we are going to discuss about this all this particular things in great detail, and we are going to develop the Verilog code. Just I wanted to give you an idea of what we are going to execute in this particular course. And also arithmetic and logic unit, where we are going to develop arithmetic ALU, multiplier, divider unit, floating point unit. And next we are going to develop the register file unit, control unit, program counter unit, and all. Next, in the memory subsystem, we are going to develop iCache, dcache, and memory management unit and memory bus interface or AXI master. We are going to see what we are going to see. Anyways, we are going to see in great detail how and what we are going to use and what is the meaning of each and every unit and where and why these are being used, right? And before discussing about this particular RISC-V IP core in great detail and all these units in great detail, I am planning one more course on computer organization COA, so that if anyone is not comfortable with this kind of units, they can able to understand this when I'm going to discuss them. So please let me know in the comment section. Do shall we have this computer organization course first? Then we will jump into this RISC-V IP code designing, and shall we start with this particular Verilog code? Now, please let me know in the comment section. And next, before that, so after developing this IP in our Verilog code, so after developing this .v file in our Verilog code, our processor will be ready. And this processor should get some instructions, right? So that particular instructions will be written in C code. So using the C code, we are going to write down whatever the instructions of whatever the process my processor should do, that we are going to write down in C. That should be converted in binary format or hexa format, and this will be stored inside my instruction memory. And from this instruction memory, my processor is going to fetch those instructions, and it is going to execute them. Now, who is going to convert this .c files into hex or binary files is RISC-V toolchain. So we are also going to see about this RISC-V toolchain, like what is this RISC-V toolchain and how we are going to use this particular RISC-V toolchain. It's basically a set of software tools which is basically used to convert a C to machine level language, such that our RISC-V CPU can execute it. So that is what we are going to learn, and we are going to understand how we are going to use them, and how to install and all, right? So this is about RISC-V toolchain, like how we are going to use it and what are the different stages which we have in our RISC-V toolchain and all. And give me a second. And next, we are going to basically this is a flow which we are going to follow. We are going to write down a C program, and the RISC-V toolchain basically have a compiler and assembler, and it is going to convert our C program into this particular files. And using the linker, it is going to generate a .elf file, and from the ELF file we are going to have dot bin and hex. So using the toolchain we are going to convert them, and this binary file or hexadecimal file will be loaded into the instruction memory, and whatever the code which we have developed, right, that code is going to fetch the instructions from our instruction memory, and it is going to execute those particular instructions, and we are going to look whether how it is performing and what is it performing and what. So this is what I'm planning for this particular RISC-V design course. Yes, so we will be starting this particular course shortly, and yeah, so that's about this particular introduction. So if you like this video, please like, share and subscribe to my YouTube channel, and please let me know like what exactly do you want in this particular course so that we can plan it. Yeah, thank you.